Infinity Labs, an open education initiative. Welcome back to our video series on the solid programming principles. In this video, we'll be continuing our exploration of these important guidelines for writing high-quality code, and we'll be focusing specifically on the Liskov Substitution Principle. LSP is a crucial principle that can help you to write more maintainable, flexible, and scalable code, and we'll be diving deep into its concepts and applications. By the end of this video, you'll have a solid understanding of the Liskov Substitution Principle and how to use it to improve the quality of your code. Liskov Substitution.
The Liskov Substitution Principle is a fundamental principle of object-oriented programming that states that any instance of a class should be able to be replaced by an instance of its subclass without affecting the correctness of the program. In simpler terms, if you have a class A and a subclass B, you should be able to use an object of class B anywhere you would use an object of class A, without breaking anything. This principle is important because it ensures that your code is more flexible, reusable, and maintainable. Here are 5 benefits of using the Liskov Substitution Principle. It promotes code reuse. By encouraging the creation of abstract classes and interfaces that can be implemented by multiple subclasses. It makes code more flexible and adaptable to changes by allowing new subclasses to be added without affecting the existing code. It helps prevent bugs and errors. By ensuring that code behaves predictably and consistently across different classes and subclasses. It improves code quality. By promoting modular, decoupled code that is easier to test and maintain. It makes code more scalable. By allowing for the creation of complex class hierarchies that can be extended and customized as needed. To use the Liskov Substitution Principle, you should follow these guidelines. Ensure that subclasses have the same behavior as their parent class. This means that all methods and properties should work in the same way across all subclasses. Make sure that subclasses do not violate any preconditions of their parent class. Preconditions are any requirements or constraints that are specified by the parent class for its methods or properties to work correctly. Ensure that subclasses do not weaken any postconditions of their parent class. Postconditions are any guarantees or assumptions that are made by the parent class about the behavior of its methods or properties. Avoid overriding or hiding methods or properties of the parent class unless it is absolutely necessary. Use abstract classes and interfaces to define common behavior and functionality that can be implemented by multiple subclasses.
Let's dive into a code example to better understand the Liskov Substitution Principle. The code example will show how to use the Liskov Substitution Principle to create a flexible and extensible system by implementing a common interface and adhering to the behavior of the parent class.
In this example, we have a parent class shape that defines the calculate area method. This method is not implemented in the parent class and throws an error if it is called. Instead, we implement this method in the 2 subclasses, square and circle. These subclasses override the calculate area method and provide their own implementation. In this example, square and circle are subclasses of shape, and they both have a calculate area method that behaves in a way that is consistent with the parent class. If we create an instance of square or circle, we can replace it with an instance of shape without affecting the correctness of the program. We also have a print area function. This function takes a shape object as its parameter and calls its calculate area method to print the area of the shape. In conclusion, the Liskov Substitution Principle is an important concept in object-oriented programming that promotes flexibility, reusability, maintainability, and scalability of code. By following the guidelines and benefits of LSP, developers can create code that is easier to test, debug, and maintain, and can more easily accommodate changes and new requirements. By using LSP in conjunction with other solid principles, developers can create high-quality, robust, and scalable software applications.